Welcome, I am Sumedha Bapat. Here today we are going to learn about quadratic equations. What actually quadratic equations means? Quadratic, the word is derived from quadra, which means square. You have learned quadratic expressions. The polynomial px is a quadratic. What it means? That means degree of polynomial is 2. When you equate that px to 0, it is quadratic equation. Now you are familiar with expansion of x plus a into x plus b. X plus a into x plus b is equal to x square plus a plus b into x plus ab. It is quadratic expression. Now when x plus a into x plus b is equal to 0, we call this as quadratic equation. When product of two terms is 0, obviously either must be 0. So x plus a is equal to 0 or x plus b is equal to 0. That means x is equal to minus a or x is equal to minus b. The values of variable x which satisfy this equation or for which equation is true are known as solutions or roots of the equation. When polynomial is of degree 2, when we equate that to 0, that is quadratic equation, it has maximum 2 roots or 2 real roots. Solving quadratic equation, that means we are finding out the roots of quadratic equation. Now again consider x square plus a plus b into x plus ab is equal to 0. We can write this as x square minus into bracket minus a plus minus b into x plus minus a into minus b is equal to 0. That means x square minus sum of roots into x plus products of the roots. In general, ax square plus bx plus c is equal to 0, whereas a non-zero, a, b, c are real numbers. Then we can write x square plus b upon a into x plus c upon a is equal to 0. That means we have divided the given equation by a only. Now observe again the equation. Coefficient of x is b by a. So sum of roots is equal to minus b upon a. That means sum of roots is equal to coefficient of x upon coefficient of x square. Product of roots is equal to c by a. That is equal to constant term divided by coefficient of x square. Now here are some examples for you. Form quadratic equations using the following roots. The roots are 5, 7, second pair is minus 9, minus 11, the third pair minus 12, 6, fourth pair 2 plus root 3 and 2 minus root 3. Fifth pair root 3 and 2 root 3. Now in polynomial, degrees of variables are non-negative. But there is no condition on coefficient. In quadratic equation, maximum degree is 2. Now, here are some examples. You are asked to find out which equations are quadratic. Number 1, x square minus 7x minus 11 is equal to 0. x square plus 1 upon x is equal to 3 by 2. And third one is x square plus root 3x plus 7 is equal to 0. Now observe equation number 1 and 3. You can definitely say that these two are quadratic equations. But what about the second one? When you simplify that, you will get the degree of expression in the LHS is 3. So this is not quadratic equation. Now another type of example. Here you are given 3x square plus twice x minus 1 is equal to 0. And two values of x are given. X is equal to minus 1 and x is equal to 2. Determine whether the given values are solution of given equation or not. Here we write x is equal to minus 1 in LHS of the given equation and simplify. So 3 into minus 1 bracket square plus 2 into minus 1 is equal to 3 minus 2 minus 1 which is equal to 0 which is equal to RHS. And therefore x is equal to minus 1 is root of given equation. You can do the similar procedure for x is equal to 2. Now one more type of example. Here you are given 2x square plus kx plus 3 is equal to 0. And one of the roots of equation is 1. And you are asked to find value of k. As one of the roots is 1, we write x is equal to 1 and it must satisfy the equation. Putting x is equal to 1 in the equation, 2 into 1 square plus k into 1 plus 3 is equal to 0. When you simplify this, k is equal to minus 5. Now, we will learn one method, that is factorization method, to solve quadratic equation. There are so many methods, but here we are going to learn factorization method. Example is x square minus 2x minus 143 is 0. Now we will solve this equation by splitting middle term. Middle term is minus 2x. So we will find two terms such that product is 143 and addition is 2x. So obviously minus 13x and plus 11x are the two terms whose sum is minus 2x and product is minus 143x square. So we write this as x square minus 13x plus 11x minus 143 is equal to 0. That is x into bracket x minus 13 plus 11 into bracket x minus 13 is equal to 0. Therefore, x plus 11 into another bracket x minus 13 is equal to 0. Obviously, the roots are x is equal to minus 11 and x is equal to 13. Now one more example. 3x square plus x minus 102 is equal to 0. Now again we are going to split middle term such that product of two terms is 3x square into 102 and their sum is plus x. So the terms are 18x minus 17x. So we write equation as 3x square plus 18x minus 17x minus 102 is equal to 0. Taking 3x common, 3x into bracket x plus 6 minus 17 into bracket x plus 6 is equal to 0. Therefore, x plus 6 into 3x minus 17 is 0. Obviously, x is equal to minus 6 or x is equal to 17 by 3. Therefore, roots of equation are minus 6 and 17 upon 3. Now one more type. 4x square minus 25x is equal to 0. Here you can easily find out the factors like a square minus b square. So the factors are twice x plus 5 into twice x minus 5. So twice x plus 5 into twice x minus 5 is equal to 0. So twice x plus 5 is 0 or twice x minus 5 is 0. Therefore x is equal to minus 5 by 2 or x is equal to 5 by 2. So the roots of equation are 5 by 2 and minus 5 upon 2. Now we'll take example such that the coefficient of x is irrational number. Here is an example. Twice x square minus root 3x minus 3 is equal to 0. Now again we will split middle term so that product is minus 3 into 2x square. So product is 6x square. And subtraction must be root 3x. So we write 6x square as 3x into 2x. Instead of 3, we write root 3 into root 3 because we want root 3 there. So we write 2 root 3x into root 3x for 6x square. As we want minus root 3x, we write minus 2 root 3x plus root 3x. So equation is now 2x square minus 2 root 3x plus root 3x minus 3 is equal to 0. So take 2x common. So you can write 2x into bracket x minus 3 and root 3 common. So you can write root 3 into bracket x minus root 3 is equal to 0. So first bracket is now x minus root 3 and another bracket is twice x plus root 3 is equal to 0. Now x minus root 3 is 0 or twice x plus root 3 is 0. Obviously x is equal to root 3 and x is equal to minus root 3 upon 2 are roots of the equation. Now one more type. You are given equation as 1 upon 2 twice x minus 1 bracket square is equal to 8. Now here multiply both sides by 2. So we get twice x minus 1 bracket square is equal to 2 into 8. That is equal to 16. So 2x minus 1 bracket square is same as 4 square. When you transfer 4 square to LHS, LHS is of the type a square minus b square. So you can write factors. So twice x minus 1 plus 4 into another bracket twice x minus 1 minus 4 is equal to 0. Adding similar terms, you will get twice x plus 3 into another bracket twice x minus 5 is equal to 0. And therefore, x is equal to minus 3 by 2 and x is equal to 5 by 2 are roots of the given equation. In this example, you can simplify or you can expand that square and add similar terms and then factorize, you will get the same solution. Now you are given equation as 25x square plus 40x plus 16 is equal to 0. Obviously, this is a complete square of 5x plus 4. So we write 5x plus 4 bracket square is equal to 0. As bracket square is 0, you can write bracket is 0. Therefore 5x plus 4 is 0. So x is equal to minus 4 by 5. Here both roots are equal. And they are equal to minus 4 upon 5. That is, roots are real and coincident. Now here is one more example. X plus 1 upon x is equal to 17 by 4. We can write this as x square plus 1 upon x is equal to 17 upon 4. Now multiply both sides by 4. So 4x square plus 4 is equal to 17x. Now we'll split middle term. Product must be 16x square and addition is 17x with negative sign. So we write 17x as minus 16x and minus x. So equation is 4x square minus 16x minus x plus 4 is equal to 0. So 4x into bracket x minus 4 minus 1 into bracket x minus 4 is equal to 0. So you can write 4x minus 1 is 0 or x minus 4 is equal to 0. Therefore, x is equal to 1 by 4 or x is equal to 4. So the roots of given equation are 1 upon 4 and 4. Now the given quadratic equation is 1 upon a plus b plus x is equal to 1 upon a plus 1 upon b plus 1 upon x. The condition given is a plus b is non-zero. Now we'll transfer the term containing x to LHS. So 1 upon a plus b plus x minus 1 upon x is equal to 1 upon a plus 1 upon b. Therefore, x minus into bracket a plus b plus x upon x into bracket a plus b plus x is equal to a plus b upon ab. Simplifying this, you can write minus into bracket a plus b upon x into bracket a plus b plus x is equal to a plus b upon ab. Now as a plus b is non-zero given, we can divide both sides by a plus b. So we get minus 1 upon x into bracket a plus b plus x is equal to 1 upon ab. Simplifying this, you can write minus ab is equal to x into bracket a plus b plus x. Now transfer minus ab to that side. So 0 is equal to ab plus ax plus bx plus x square. Now when you factorize this, you can write 0 is equal to x plus a into bracket x plus b. Obviously x is equal to minus a and x is equal to minus b. So minus a and minus b are roots of the given equation. Now we learn a new method, that is solve quadratic equations by completing square, or you write square method. You are given an equation x square minus x minus 56 is equal to 0. So first step is transfer the constant term to RHS. So we write the equation x square minus x is equal to 56. We'll make LHS as a complete square. So the required third term or required square term is coefficient of x into 1/2 bracket square, and that is equal to minus 1 into half, that is minus 1/2, and square of that is 1 by 4. So adding 1 upon 4 to both sides, we get x square minus x plus 1 upon 4 is equal to 56 plus 1 upon 4. So x minus 1 bracket square is equal to 225 upon 4, which is equal to 15 upon 2 bracket square. So taking square root of both sides, you can write now x minus 1 upon 2 is equal to plus minus 15 upon 2. Therefore, x is equal to 1 upon 2 plus minus 15 by 2. When you simplify this, you can write x is equal to 16 by 2, which is equal to 8, and x is equal to minus 14 upon 2, which is equal to minus 7. So 8 and minus 7 are roots of the given equation. Again you observe the equation, which is x square minus x minus 56 is equal to 0. If you split the middle term, you can easily write two brackets, that is x minus 8 into another bracket x plus 7, and the roots of equation are 8 and minus 7, which are same as here. Now one more example. It is twice x square minus x minus 3 is equal to 0. Now here coefficient of x square is 2. So we divide the equation by 2 and we get x square minus 1 upon 2x is equal to 3 upon 2. And required square term is minus 1 upon 4 bracket square, which is equal to 1 upon 16. So we add 1 upon 16 to both sides and we get x square minus 1 upon 2 into x plus 1 upon 16 is equal to 3 by 2 plus 1 upon 16. Now LHS is complete square of x minus 1 upon 4. So we write x minus 1 upon 4 bracket square is equal to 5 by 4 bracket square. Therefore, x minus 1 upon 4 is equal to plus minus 5 by 4. Therefore, we can write x is equal to 1 upon 4 plus minus 5 by 4. Simplifying this, we can write x is equal to 6 upon 4, that is 3 by 2, or x is equal to minus 4 upon 4, that is minus 1. So 3 by 2 and minus 1 are roots of the given equation. One more equation. 3x square plus 12x minus 7 is equal to 0. Now first we will transfer constant term. So we get 3x square plus 12x is equal to 7. Now divide the equation by coefficient of x square. So we divide the equation by 3. Therefore x square plus 4x is equal to 7 upon 3. Now required third term or square term is equal to coefficient of x into half, that is 4 into half, and square of that, which is equal to 4. So we add 4 to both sides. Therefore we get x square plus 4x plus 4 is equal to 7 upon 3 plus 4. Simplifying this, we can write x plus 2 bracket square is equal to 19 upon 3. When you take square root of both sides, it is x plus 2 is equal to plus minus under root of 19 upon 3. So x is equal to minus 2 plus under root 19 by 3, or x is equal to minus 2 minus under root 19 upon 3. Here roots of this equation are irrational. Now consider this general equation, ax square plus bx plus c is equal to 0. If we solve this equation by completing square method, we get x is equal to minus b plus minus under root of b square minus 4ac upon twice a. We can use this as a formula, and we can use this formula to find solutions of given quadratic equation. Now here under root of b square minus 4ac decides the nature of roots of given quadratic equation. If square root of b square minus 4ac is rational, then the roots are rational. If it is irrational, then the roots are irrational. This b square minus 4ac is denoted by delta or capital D. So we write delta as b square minus 4ac, or we can write D is equal to b square minus 4ac. Now how to decide nature of roots? If delta is greater than 0, the roots of equation are rational or irrational, and they are unequal. If delta is equal to 0, then it is a complete square. So the roots are rational and equal, or they are coincident. If delta is less than 0, then under root of negative number is not a real number. So when delta is less than 0, the roots are not real. Now we solve some examples. Find value of D of equation 6x square minus x minus 2 is equal to 0. Here a is equal to 6, b is equal to minus 1 and c is equal to minus 2. b is equal to b square minus 4ac. We substitute values of abc here and simplify. So d is equal to 49. One more example. 3x square plus 2x minus 8 is equal to 0. By using formula, we can solve this equation. Here a is equal to 3, b is equal to 2 and c is equal to minus 8. So first find value of d, that is b square minus 4ac. Substitute values of abc. We get d is equal to 100. And this 100 is perfect square. It is greater than 0. So the roots are rational numbers. We substitute this value of d in formula. So x is equal to minus b plus minus under root of b square minus 4ac upon 2a. When you substitute values, you get minus 2 plus minus 10 upon 6. So the roots are 12 upon 6 or minus 8 upon 6. So it is 2 or minus 4 upon 3. Now one more example. 4x square minus 12x plus 9 is equal to 0. In this equation, a is equal to 4, b is equal to minus 12, c is equal to 9. Now what is value of d? b square minus 4ac is equal to minus 12 square minus 4 into 4 into 9. So 144 minus 144, which is equal to 0. That means value of d is 0. So this equation have real and equal roots. Which are they? LHS of the given equation is twice x minus 3 bracket square, which is equal to 0 now. So twice x is equal to 3 and x is equal to 3 by 2. So the roots of this equation are 3 by 2 and 3 by 2, that means the roots are equal or roots are coincident. Now one more example. Twice x square minus 7x minus 6 is equal to 0. Here a is equal to 2, b is equal to minus 7, c is equal to minus 6. So b square minus 4ac is equal to minus 7 square minus 4 into 2 into minus 6, which is equal to 49 plus 48, which is 97. So we write value of x as minus b plus square root of d upon 2a and minus b minus square root of d upon 2a. Therefore, 7 plus square root of 97 upon 4 and 7 minus square root of 97 upon 4. These are two values of x. We denote these two values. We use alpha for one value and beta for another. So alpha is equal to 7 plus under root 97 by 4 and beta is equal to 7 minus under root 97 by 4. So the roots of this equation are irrational, they are real and unequal. Now here is an example. X square plus 4x plus 6 is equal to 0. Here a is equal to 1, b is equal to 4 and c is equal to 6. What is d? d is equal to 4 square minus 4 into 1 into 6. That is equal to 16 minus 24, which is equal to minus 8. And minus 8 is less than 0. And under root of minus 8 is obviously not a real number. So the roots of this given equation are not real. Now we'll find given unknown in the equation using the nature of roots. If it is given, take example, find value of k if given equation has real and equal roots. Equation is 2x square minus 10x plus k is equal to 0. Here a is equal to 2, b is equal to minus 10 and c is equal to k. Now when you substitute values, minus 10 square minus 4 into 2 into k, that gives you 100 minus 8k. But you are given roots are equal and real. So we equate this to 0. So 100 minus 8k is equal to 0. Simplifying this, you can write k is equal to 25 upon 2. Now one more example. 4 minus m into x square plus twice m plus 4 into x plus 8m plus 1 is equal to 0. And you are given roots of this equation are real and equal. And you are asked to find value of m. Now you are given roots of this equation are real and equal. Obviously, LHS must be a complete square. And d is equal to 0. Coefficient of x square, that is a, is equal to 4 minus m. value of B is equal to twice m plus 4 and value of C is equal to 8m plus 1. Substituting these values in B square minus 4AC, we get 4m square plus 16m plus 16 minus 4 into bracket 31m minus 8m square plus 4. And simplifying this, we get 36m square minus 108m. Now we'll equate this value to 0. So 36m square minus 108m is equal to 0. So we take 36m as a common. So 36m into bracket m minus 3 is equal to 0. That gives you m is equal to 0 or m is minus 3 is equal to 0. That means value of m is either 0 or 3. Now here is one example, a different type. You are given example as c square into minus ab into bracket x square minus 2 into bracket a square minus bc into x plus b square minus ac is equal to 0. And roots of this quadratic equation are equal. So first we will write coefficient of x square, coefficient of x and constant term. Coefficient of x square is c square minus ab. That of x is 2 into bracket b square a square minus bc. And constant term is b square minus ac. As roots are equal, d must be 0. So let us find value of d and equate that to 0. So substituting values of coefficients of x square, x and constant term and simplify this, we get 4a into bracket a cube plus b cube plus c cube minus 3abc. And obviously we equate this to 0. So 0 is equal to 4a into bracket a cube plus b cube plus c cube minus 3abc. As product of these two terms is 0, either must be 0. So a is 0 or a cube plus b cube plus c cube minus 3abc is 0. That gives you a cube plus b cube plus c cube is equal to 3abc and hence the proof. Now we will discuss about word problems. That means this is application of quadratic equation. Now here are important points to solve quadratic word problems. First, read the given problem very carefully. Understand the problem. Then write what is given to you. Write what you are asked to find out. And from these two, convert the given information using mathematical symbols and variable and signs. That is, you should formulate the given information in equation and then try to solve the equation and find the solution. When you get two values of that variable which you have assumed, again read the problem and decide which value is not acceptable and which value is acceptable. If both are acceptable, well and good. If one is acceptable, one is not, then you should mention why the value is not acceptable and then proceed. And then write your answer or then write the solution. So here is one problem. You are given the product of two consecutive odd natural numbers is 195 and find the numbers. What is given to you? The numbers are natural and consecutive. They are odd consecutive. The difference between two odd consecutive numbers is 2. So when you assume one number is x, obviously another number is x plus 2. So we write equation as x into bracket x plus 2 is equal to 195. When you open the bracket, you will get x square minus 2x minus 195 is 0. And obviously you can solve the quadratic equation splitting middle term. You can write x is equal to minus 15 and x is equal to 13. But you are given the numbers are natural. And obviously minus 15 is not a natural number. So x is equal to minus 15 is not acceptable. So we write x is equal to 13. And obviously x plus 2 is 15. So the two consecutive odd natural numbers are 13 and 15. Now consider one more example. 7 years ago, Amit's age was 5 times the square of Mukta's age. 3 years hence, Mukta's age will be 2/5 of Amit's age. Find their present ages. In this example, though you are asked to find out present age, it is easy to assume the age before 7 years. So, I will assume Mukta's age 7 years ago be x years. And therefore present age is x plus 7 years. And Amit's age before 7 years is 5x square according to conditions. And present age is 5x square plus 7. So after 3 years or 3 years hence, Mukta's age will be x plus 10 years and Amit's age will be 5x square plus 10 years. Now from given conditions, what is given to you? Mukta's age will be 2/5 of Amit's age. So write Amit's age, multiply that by 2 by 5 and equate that to Mukta's age. So we write equation as x plus 10 is equal to 2 upon 5 into bracket 5x square plus 10. Simplifying this, you can write x plus 10 is equal to 2x square plus 4. When you transfer the terms, you will get 0 is equal to twice x square minus x minus 6. Again, split middle term and you can write 2 factors. So 0 is equal to twice x plus 3 into another bracket x minus 2. What are values of x? You will get x is equal to minus 3 by 2 or x is equal to 2. Now again here, as x is Mukta's age before 7 years, it is not negative, it will never be negative. So x is equal to minus 3 by 2 is not acceptable. So we write x is equal to 2. And Mukta's present age is equal to x plus 7, that is 2 plus 7, which is equal to 9. And what is Amit's present age? It is 5x square plus 7, which is equal to 20 plus 7, which is equal to 27 years. So your answer is Mukta's present age 9 years and Amit's present age is 27 years. Now let us take one more example. You are given length of a rectangle is 3 meters more than 3 times the breadth of the rectangle. If its diagonal is 25 centimeter, find length, breadth and area of the rectangle. Now here, length of rectangle is given in terms of breadth. So we assume breadth of rectangle is x meter. And length of rectangle obviously is 3x plus 3 meter. You are given diagonal as 25 meter. You know all angles of rectangle are 90. So when you draw diagonal, you will get right angle triangle. So we'll use Pythagoras theorem here. So using Pythagoras theorem, we can write x square plus 3x plus 3 bracket square is equal to 25 square. Simplifying this, we get 10x square plus 18x plus 9 minus 625 is equal to 0. Simplify this, you can write 5x square plus 9 minus 308 is equal to 0. Now you want product as 308 into 5x square and addition of two terms is 9x. That means we are going to split middle term 9x. Now find pairs of two numbers such that the addition between two is 9x. Product will be negative and their addition is 9x. So equation is 5x square plus 44x minus 35x minus 308 is equal to 0. Simplifying this, you will get x is equal to 7 and x is equal to minus 44 upon 5. Again, as side of a rectangle is never negative, so we don't accept value minus 44 by 5, and so x is equal to 7. And obviously length is 3 into 7 plus 3, that is 24, and breadth is 7. So what is area now? Area is length into breadth. So 24 into 7, and that gives you area of rectangle is equal to 168 meter square. Now the example is, if two pipes function simultaneously, a water tank will be filled in 12 hours. One pipe fills the tank 10 hours faster than the other. How many hours will the second pipe take to fill the tank? Now here, when two pipes function simultaneously, the time required is 12 hours. If you assume one pipe takes 6 hours to fill the tank and another pipe obviously takes x plus 10 hours to fill the tank. So if only one pipe is working, in 1 hour 1 upon x tank will be filled. And if another pipe is working, in 1 hour 1 upon x plus 10 tank is filled. So if the two pipes work simultaneously, 1 upon x plus 1 upon x plus 10, this much tank is filled in 1 hour. So from given condition, what is given? If two pipes work simultaneously, tank is filled in 12 hours. So we write equation as 1 upon x plus 1 upon x plus 10 is equal to 1 upon 12. Now when you simplify this, that is x plus 10 plus x upon x into bracket x plus 10 is equal to 1 by 12. Simplify this, you can write 0 is equal to x square minus 14x minus 120. Split the middle term and write the factors. So 0 is equal to x minus 20 into bracket x plus 6. Obviously x is equal to 20 and x is equal to minus 6. the time required to fill the tank is never negative. So obviously we will not accept value x is equal to minus 6. So x is equal to 20. So one pipe takes 20 hours to fill the tank, and another pipe takes 20 plus 10, that is 30 hours to fill the tank if that pipe functions alone. Now here are examples for practice. Number 1. A plane left 30 minutes later than the scheduled time in order to reach its destination 1500 kilometers away. It has to increase its speed by 250 kilometers per hour in usual speed. And example number 2, the sum of two numbers is 30 and the sum of their reciprocals is 5 by 36. Find the numbers. Now try to solve these problems. Thank you.